In this video, we're going to talk about what we call solving right triangles, and we'll do a few word problems as well. But what we mean by solving right triangles is to find all the measurements of all 6 parts of the triangle. The 6 parts being the 3 sides and the measures of the 3 angles. So I'm going to find all the sides of the triangle and then find all of the angles of the triangle. All right, so typically in a triangle, if you know one of these angles in a right triangle, you can easily find the other. So I would suggest starting there if that's the case. So 90 minus 52, that'll give us 38 degrees. So we're done with those 3 parts. So we have 52, 90 degrees, and 38 degrees. Now to find the other 2 sides of the right triangle, we have to do a little SOHCAHTOA because we can't use Pythagorean theorem without knowing at least 2 sides. So let's set that up. I'm going to use the 52 that was given. I always like to use what was given just in case I made a mistake in finding some of the other pieces. So I'm going to find the opposite side, A, and I'm given the adjacent side, 19. So opposite over adjacent, that is TOA, so tangent of 52 degrees is going to be equal to A over 19. And then remember, I'm going to cross multiply, so I'm going to do 19 times tan of 52 degrees is equal to A. If I type that in, I get roughly A is 24.32. Okay, so that's what I'm getting for that side. Now at this point, I have 2 sides. I can use Pythagorean theorem, or I could do SOHCAHTOA again, just with using a different trig ratio. So I'm going to show you both ways. If I was doing Pythagorean theorem, we would do 19 squared plus 24.32 squared. That would equal c squared. So 19 squared is 361, and then the 24.31 squared, I got about 591. If I add those together, 952.40846, and then square root that, and I'm getting C is roughly 30.86. So that's one way to get that last side. The other way would be to go back to the angle and side we're given, and I would be using the adjacent and hypotenuse. So that means the cosine. So cosine of 52 degrees is equal to 19 over C. If we cross multiply, and then divide by the cosine, I'm typing this into my calculator, 19 divided by cosine of 52. So C is going to be roughly 30.86. So either way, we're getting the same answer. My personal preference is I like doing the SOHCAHTOA way for both of them, because if I keep the cosine of 52 in my calculator, then I'm not rounding in the middle. Whereas over here, I had a round. For the Pythagorean theorem, I had a round there. This was rounded. This was rounded. So I had to keep rounding. So sometimes that'll make our answers off if we do it that way. So just FYI. All right, so we can use this to solve problems. And I've shown you a few, but let's look at this one. We have a surveyor is 130 feet from a tower, which is 86 feet high. So this tower is 86 feet high from here to here. All right, and the surveyor is 130 feet from the tower. Okay. The surveyor's instrument is 4.75 feet above the ground. So I need to really make this line a little bit different. So he's kind of looking at this instrument on a tripod, And that triangle is looking like that. Now, is that still 130 feet? Absolutely. But it's just, and then 86 feet is the whole distance down to the ground. So just keep that in mind. And this height right here is 4.75 feet. Okay, they want us to find the angle of elevation. All right, so angle of elevation, remember that goes diagonally. If he's looking straight across and then tilts his head up to the top of the tower, then this is our angle of elevation. And I'm going to put, remember that Greek letter theta, I'm going to put theta there. That's what we're trying to find. So far all we've been doing is finding sides, and now we need to figure out how do I find the angle. All right, so first of all, I want to make sure we understand that in this triangle, right here, this side is not 86, it's 86 minus the 4.75. So this is really 81.25. Okay, so I'm using 130 and 81.25. The 130 is adjacent to that angle, and the 81.25 is opposite. So I still know that I'm doing opposite and adjacent, which is tangent. It's just I don't have the degree measure this time. I just have theta. I don't know that. And then I can fill in those side lengths. So that's 81.25 opposite over adjacent over 130. So what I'm going to show you next is how do I solve an equation like this? Because I can't type in tangent of theta into my calculator. So what we have is the idea of inverse trig ratios. This is just doing the opposite, right? It's undoing something. It's going backwards, just like we're trying to do in that word problem. So if I know that the tangent of A is equal to some ratio, then if I do the inverse tangent of that ratio, then it gives me the measure of that angle. So for example, if I was doing angle A here, and this is the opposite and adjacent, I know the tangent of A is BC over AC right there. So what we're going to do is on our calculator, we're going to do the inverse tangent of that ratio. So look at your calculators right now. You should see above your sine, cosine, and tangent buttons, you should see sine with a little -1 on it, cosine with a little -1, and tangent with a little -1. Those are called inverse sine. So inverse sine, inverse cosine, inverse tangent. All right, so if you hear me say inverse with that -1, that's what we mean. Okay, it doesn't mean raised to the -1 power or anything like that. It just means it's the opposite. So you will be using your second button on your calculator when you do this. So going back to our word problem, in order to figure out what theta is equal to, we're basically doing the inverse tangent of this ratio. So keep in mind, when you do regular tangent, you're typing in an angle right after it. If you're doing inverse tangent, you're typing in the ratio after it. So make sure those are inverse operations of each other, just like adding and subtracting are opposite. So make sure you are typing in the correct item after each thing you're in your calculator. So let's do that. Okay, take your calculator, do second tan, and then we're typing in 81.25 divided by 130. So my calculator is giving me 32.0054. Okay, so I would round that to be about 32 degrees. Okay, so we would know that this angle right here is roughly 32 degrees. Okay, so that's the new thing that you're learning in this video. So let's do that again. So talking about another word problem. At a certain time, a vertical pole, which is 3 meters tall, okay, and that's how tall it is, casts a 4-meter shadow. Now, keep in mind, anything with shadows, it has to go where the sun is. So if the sun is giving out rays, right? Okay, here's the object. It has to cast a shadow down like this. Okay, and then here's the ground. So the shadow is down here. Here's the shadow of the pole on the ground. And then it has to be on the opposite side of the sun. So make sure you are aware of that. All right, there's our right angle. And our shadow is 4 meters long. Okay, so what is the angle of elevation of the sun? So they're asking us for this angle right here. Angle of elevation goes between horizontal and diagonal. So we want to know what is this angle right here. Okay, I'm going to call that theta again. All right, so what are we using? We know that opposite of that is the 3 meters. That's the opposite side, and 4 meters is the adjacent side. So again, we're working with tangents. Tangent of theta is equal to 3 over 4. Notice that when I'm using regular tangent, I write the angle right after it. That's the theta. But since I don't know that theta, I can't type in regular tangent into the calculator. So we know that theta is going to be the inverse tangent of the ratio that we have already set up, 3 over 4. So type that into your calculator. Inverse tangent of 3 divided by 4. I'm getting in my calculator about 36.87 degrees. Okay, so depending on how they want you to round that. All right, so that angle of elevation of the sun is 36.87 degrees. That's how high the sun is up in the sky. All right. So keep in mind that not all word problems are finding the angle, so you want to be able to be versatile. So make sure you read each one individually. So Tyler is 180 centimeters tall. All right, here's Tyler. He's 180 centimeters tall. And Josh is 90 centimeters tall. Who casts the longer shadow? Tyler when the sun is 70 degrees. Okay, so Tyler has his own sun, right? And his sun is at 70 degrees. So we want to know about his shadow. So this is what we're trying to find. Or is it Josh? He has his own sun when it is 35 degrees. Okay, so we were talking about his shadow. So let's call that y. So we're going to compare x and y and see which one is longer. Okay, so this is just our normal SOHCAHTOA setup. We're using the opposite, and we're trying to find the adjacent side in both of them. Here we know the opposite, and we're trying to find the adjacent. So again, we're using tangents. Tangents of my angle, which in this one is 70 degrees, is equal to 180 over x. So you can see that I have my degree measure. I'm going to use regular tangent in my calculator. Cross multiply, and then divide. So I'm typing into my calculator 180 divided by tangent of 70. Once again, I'm not trying to find an angle, I'm trying to find a side, so I use regular tangent. And I'm getting 65.5 centimeters. Over here, its tangent of 35 degrees is equal to 90 over y. So if we cross multiply and divide, I'm doing 90 divided by tangent of 35 degrees. So type that in. And I'm getting 128.5 centimeters. So Josh's shadow is longer because his angle of elevation is not as high. I don't know if you noticed that or not, but like when the sun is lower on the horizon, you have longer shadows, and that makes sense. So now, how does this affect our 45, 45, and 30, 60, 90 triangles? These are values that I want you to memorize. Again, this will help you immensely when you're in Honors Algebra 2 Trig. But if I'm doing the sine of 45, let's say I'm using this 45. This is opposite, adjacent, hypotenuse. Okay, the sine of 45 is 1 over the square root of 2, and we don't leave it like that. So we rationalize, and that's going to give me the square root of 2 over 2. Now if I do the cosine, cosine will also be 1 over square root of 2. So that'll be square root of 2 over 2. And then tangent is going to be opposite over adjacent, so that's just plain old 1. So these values are values that I want you to remember. So it's kind of nice for a sine and cosine of 45. It's the same thing, square root of 2 over 2. For tangent, it's 1. And then for 30, 60, 90 triangles, we're saying that a 30 across from the 30 is 1, which makes the hypotenuse 2, and then the side across from the 60 is root 3. So the sine of 60, so now I'm doing this, so that's opposite, adjacent, and this is hypotenuse. So opposite over hypotenuse is square root of 3 over 2, and that's simplified already. Cosine is adjacent over hypotenuse, so that's 1/2. And then tangent is square root of 3 over 1, which is the same thing as square root of 3. All right, so the reason I'm pointing these out to you, these are nice numbers. They're not, well, some of them are decimals, but they're able to be written as exact answers with square roots in them. Now let's go to the other angle, 30. So that would make this side the opposite and this side the adjacent for 30. So the sine of 30 is 1 over 2. The cosine of 30 is adjacent, so that's square root of 3 over 2. And then the tangent is opposite over adjacent, 1 over the square root of 3. Here we're going to have to rationalize that. I don't know if you recognize this or not, but if you look at the 60, the 30s are just the reciprocals, or they're switched. So the sine of 30 is the same as the cosine of 60. The cosine of 30 is the same as the sine of 60. And then the tangent of 60 and the tangent of 30 are just reciprocals of each other. So that's kind of nice. All right, so those are the ones that if you see this table, there's lots in this table, but really I'm only concerned about those highlighted values that we just talked about. Those are the ones that I want you to memorize, okay? So for 30 degrees, 45 degrees, and 60 degrees, I want you to be able to come up with those values without using a calculator.